Hello friends, in today's video we're making an exciting project on cascading LED chaser pattern using an Arduino Uno. Make sure to like the video and don't forget to subscribe to the channel so that you don't miss any video. Let's start. First, let's grab our parts from the component menu. We need an Arduino Uno, a breadboard, 6 LEDs, and 6 220 ohm resistors. Next, we need to search for our light-emitting diodes, or LEDs. Type LED into the search parameter input. Drag out the first LED and carefully place its terminal pins into the breadboard sockets. Repeat this exact step 5 more times until you have all 6 LEDs securely lined up on the board space. Them out completely evenly, leaving exactly 2 empty terminal rows between each device. This structural gap ensures your layout looks professional, neat, and symmetrical. Click on each individual LED component icon to open its configuration property popover pane. You can choose to leave them all on the default red color setting, where you can change each one to green, yellow, blue, orange, or white to build a custom color layout. Now, we absolutely cannot connect our LEDs directly to our power source pins, or the excessive electrical current will blow them out instantly, that we must install current limiting protection. Search for resistor in the component menu pane. Drag out 6 individual resistors and connect one terminal to the short, straight leg, which is known as the cathode terminal, of every single LED device on the board. Make sure you click on each resistor module individually to verify its resistance property values to be by default. Tinkercad sets new resistors to 1 kilo ohm, which blocks way too much current and makes your LEDs completely dim. Double-click the number field, type 220, and change the unit drop-down selection menu from kilo ohms to regular ohms. Repeat this verification sequence for all 6 resistors across the entire breadboard to ensure balanced current flow. Next up, let's handle the ground wiring to complete our electrical circuit loop pathway. Look at your virtual Arduino board layout graphics and locate the terminal labeled G&D, which stand for ground. Click. Once on that G&D pin socket, drag your mouse cursor over to the long negative terminal rail on the breadboard layout, and click again to drop the wire. Let's color this wire completely black because standard electronics protocol says ground wires should always be black. This makes it way easier to track your power pads later. Now, let's connect the remaining open side of our current limiting resistors directly to that same negative ground bus rail line. With our ground circuitry pathways completely finished, we just need to run our individual signal wire connections that we're going to connect the long, bent terminal legs, which are known as the anode terminals, of our 6 LEDs directly to the high-number digital output pins located on the Arduino microcontroller board frame. For this specific tracking circuit configuration, we will use digital input-output pins 8, 9, 10, 11, 12, and 13. Let's start with our very first LED device positioned on the far left side. Click once on its long anode leg wire connection point. Drag your mouse cursor smoothly across the grid workspace canvas over to digital pin 8 and click to lock the wire in place. Move directly to the second LED device right next to it. Click its long anode leg terminal and run a connection wire straight to digital pin 9. Then, continue connecting the remaining 4 LEDs in exact chronological, sequential numerical order to digital pin 10, digital pin 11, digital pin 12, and finally digital pin 13.I. Highly recommend color-coding these signal lines as you go. For example, make wire 8 bright green, wire 9 yellow, wire 10 blue, wire 11 orange, wire 12 purple, and wire 13 pink. IT looks awesome and makes troubleshooting mistakes incredibly simple if something goes wrong during our testing process. Now that our physical hardware layout assembly is completely done. Look at the top right-hand corner of your Tinkercad web application screen and click on the blue button labeled code.by. Default, it will slide open the control block parameters. Let's start by programming our very first light element connected to digital pin 8. Go ahead and look into your blocks menu on the far left column panel space. Locate the blue block section and drag out a block that reads set pin to high. Drop it right onto the empty coding workspace background arena. Click on the pin number drop-down selection input field on that specific block layout. Scroll through the numbers and change the target digit to pin 8. Setting A. Microcontroller pin parameter to high tells the internal chip logic to send a full 5 volts of electrical power output straight down that specific wire path, which successfully turns our first LED indicator on. But if the program executes this action and moves on instantly, the light will turn on and turn off so fast that human eyes cannot even register the flash event that we need to force the execution thread to pause for a brief moment in time. Go over to the orange control block menu column on the left side, grab a block labeled weight, and snap it directly beneath your blue pin 8 configuration block module structure line. Change the input value parameter inside this orange weight box from 1 second down to 0.2 seconds. This 0.2 second delay duration gives us the perfect timing threshold for a fast, snappy, highly responsive animation sequence loop. As you can see, it's done, and now it's time to check. Let's start simulation, and you all can see all 6 LEDs are running in pattern. Thanks for watching this video. Make sure to hit like button, and don't forget to subscribe to the channel.